Hey yo, Victor here, and I know it's cringe that I grab my microphone like this, but it just broke on me. This video has been recorded like 3 months after doing the editing. I want to make another video like this one, but explaining the tool, showcasing it better, getting to things in a slower pace. But the thing is that this is more of a shout out that if you know someone who is interested in adding like a Pokémon bank or alike functionality to their, in this case, Generation 2 RomHack, I'm actually interested in, instead of having it like in this video in a separate Windows GUI, I want to have it inside of the ROM itself. So maybe one flag inside of the game would actually trigger calls to the API, and you know, you can use the Pokemon bank inside of the RomHack, similar to what Pokemon Crystal Clear, I think, does with their Discord bot, where you upload a save file, but you know, real time. So if you know someone or you are actually making a RomHack, please contact me. And other than that, please enjoy the video. It's been a few years since I last picked up a Pokemon game, and to be honest, I miss it. But the thing is that the last Pokemon game that I actually bought was Pokemon Emerald. Yeah, that's right, 2005. As I dusted off my old Game Boy Color and started thinking about those days, I realized something. There was no real way to seamlessly trade or store Pokemon from those older generations. I mean, sure, you can send Pokemon from Gen 1 onward to new games, but have you seen the process? Like, it's a bit of a mess, honestly. I didn't want to deal with all that hassle. All I really wanted to do was just like fire up Pokemon Crystal and enjoy the nostalgia. Of course, I wanted to play it with my girlfriend so that we could play co-op and send and trade Pokemons. But here's the catch. I wanted to do all this without relying on Nintendo services, and I also didn't want to rely on save data ruining my playthrough. I wanted real-time trading, all while playing the emulator. And that's when I realized that in 2025 there still isn't a seamless way to emulate proper GVC cable over the internet. Even 10 milliseconds of delay is too much for how the serial connection works in the Game Boy. There's no real way to emulate this unless you're playing on local network, since the latency is going to be really low. So what are the solutions for the average person trying to trade Pokemon with their friends online? Well, the first one is screen sharing two emulators on the same machine, which is not exactly practical, and it's also dangerous depending on who you're sharing your screen with. Maybe you could be using Hamachi, or you know, you don't really know what the other person is going to do with your computer if it has full access. Another way that actually comes to mind, and I think that's how my old boy and my boy actually work on the Android Play Store, is that you would be running two emulators locally on each device, and then you'd be exchanging the save data of the other players, so both players will have a copy of their save data and the enemy's save data, enemy or player 2, and then you'd be syncing only inputs frame by frame, sending at least 60 packets per second and receiving another 60 packets per second of only raw input data, and you would be halting the emulator until you receive those 60 packets every second. That way you're actually not emulating the link cable over the internet, but you will be only sending like the input data on every frame, and will be much more cost effective, and you'll be emulating the link cable just locally on the loopback interface. Since I really didn't like any of those options that much, I thought about just taking matters into my own hands and decided to make a system of my own. So buckle up, because we are about to dive deep into some serious tech talk. So I'm gonna be completely honest with you guys, I totally forgot to record some footage of the tool working, so in the next few seconds I'll be showing you me uploading and downloading some Pokemons to my custom Pokebank, and I will also be showcasing multiple accounts, multiple emulators, pointing out that you can use it with several ROM hacks that do not actually change the memory structure. So you can also create one account and use it with multiple people to actually perform trades. So without further ado, let's go with the video. The first challenge that popped into my head was figuring out how to communicate with the emulator to pull data from the game. Now, I didn't want to get bogged down learning new languages or scripting environments like Lua or Python specifically for emulators, so instead I took the road less traveled and built my own wrapper. To figure out the best approach, I tried 4 different languages: Python, C#, Java, and AutoHotKey. So let me tell you, Java and I don't get along, especially when it comes to desktop apps. It just feels clunky to me. I've never done a GUI in Python, and I didn't want to go down the Visual Studio road either, so I opted for AutoHotKey, a language I felt comfortable with, even though it was a bit of a pain in the neck. But hey, comfort over convenience, right? While I could have easily gone with C# and WPF for a cleaner solution, I decided to roll up my sleeves and stick with AutoHotKey. For my memory and UI functions, I tapped into a library I started working on a few months ago called GBA-MEM, which handles reading and writing to emulators for Game Boy, Game Boy Color, and Game Boy Advance systems. I also reused a memory mapper I made for a past project, specifically the Crystal mapper. I only had to customize it to just pull the Pokemon team data directly from the running game and call it a day. Next up, I needed a place to store the Pokemon data. Since I didn't want it to live in a local database, I turned an old PC with XAMPP installed into my server. XAMPP comes with a MySQL instance out of the box, so I got to work building a database to store users, games, Pokemon, and well, that's pretty much it for the basic structure. For the API, I chose the ever-reliable Spring Boot framework. I am mainly using Spring Data for the database and Spring Security to keep things locked down, so I set up the usual suspects: entities, controllers, services, DTOs, and mappers, and of course the main server's config. Once I got the security and authentication manager configured, my API was already JWT secured and ready to handle requests. Plus, I threw in Spring Actuator for monitoring and pulling some metrics for my Prometheus backend. Now here's where things got a little tricky. I needed to deploy the API on a machine inside a DMZ, and the database was on a completely different network. To make it all talk to each other, I'm using Zalando Skipper as a reverse proxy. This setup will allow me to access both the DB and the API through a single endpoint on yet another machine. And because Skipper is a beast, it's also going to handle HTTP proxying, load balancing, and rate limiting for critical endpoints. Quite the Swiss Army knife, to be honest. I briefly considered using Jenkins for the deployment pipeline, but let's be real, once this thing is built, I'm not gonna be maintaining a pipeline for it, so instead I'm going the simple route with the GitHub API to auto-update both my backend and my front-end app. So once everything was in place, it was time to test things out with Postman. I created a Postman collection to demonstrate how each endpoint worked and to test them out. I also got to play around with my Prometheus metric endpoint using metric.cat. After making sure everything was locked down and working smoothly, I mapped out the API calls on the client side, starting with the authentication. Then I started adding features for uploading and downloading Pokemon data from the emulator to the API and vice versa. Now the UI was next. I kept it simple but functional. I added some background music loops, a status indicator for the API, and views for logging in, uploading, and downloading Pokemon, and also a detailed viewing for each Pokemon that you will select. I also added a custom cursor for the extra touch. Now instead of packing every Pokemon image into the app, I set up an on-the-fly image downloader using an API, and then I implemented caching for the images I had already downloaded. This way, I won't overload the API with requests, and the application will run smoother. Once everything was polished, I ran some tests before packaging everything into a Docker container. After fully testing the app, I created a self-contained jar file and deployed it in a Docker container. And voila, it's now running flawlessly in its isolated container environment. As the system's been running, I've been collecting some really interesting data using Prometheus and displaying it once again using metric.cat. I'm not running full Grafana here since the data that I'm collecting is actually meaningless for me.
Hey yo, what up? It's me from the future, and I just wanted to point out that I wanted to get into more details into some parts of the process, like how I actually extract the memory from the emulator and translate it, but I didn't want to make the video like too heavy, and I'm also not that used to editing yet, so if you have doubts about some specific parts of the process, you can ask for them in the comment section. Maybe there are high chances that I'll be explaining it further in a separate video, so having said that, let's continue.
And there you have it, a deep dive into how I built this clone of Pokemon Home. It's been quite a journey, but it works like a charm, so stay tuned for more updates. So while I was doing this video, I thought about connecting this project with another project that involves shiny hunting Pokemons, and I made it multi-instance last week so I can run multiple emulators and hunt faster. Now, shiny Pokemons, for those who don't know, are actually those that only appear once in 8192 encounters, so they're pretty rare to come by and they have a different color. So maybe an idea for a future video would be to upload them to this new Pokemon Home API, I don't know. If you reached this point, thank you. Give it a thumbs up if you liked it, subscribe, it will help me a lot, and share it with your friends. And well, see you in the next video. Bye.